We're given f of x comma y equals xy, and asked to determine the gradient of f at the point -3, comma 2. You'll also hear this referred to as del f. So looking at our notes below, given the function f of x comma y, and that the partial derivatives exist, then the gradient of f is equal to the vectored valued function, where the x component is equal to the partial of f with respect to x, and the y component is equal to the partial of f with respect to y. So we'll first find the gradient of f, and then we'll discuss what it means, as well as show it graphically. So again, the gradient of f is equal to the vectored valued function, where the x component is equal to the partial of f with respect to x, and the y component is equal to the partial of f with respect to y. So in our case, we'll have the gradient of f is equal to, for the x component, we want to find the partial derivative of f with respect to x, which would be the partial derivative of xy with respect to x. So we differentiate with respect to x, treating y as a constant, and therefore the partial derivative would just be y. The y component is equal to the partial of f with respect to y. When we differentiate xy with respect to y, we treat x as a constant, and notice how the partial derivative with respect to y would just be x. Now we'll evaluate this at the point -3, comma 2. So the x component is equal to y, which is 2. The y component is equal to x, which is -3. So the gradient of f at the point -3, comma 2 is a two-dimensional vector with components 2, comma, -3. Now let's talk about what this means, and then we'll look at it graphically. The direction of maximum increase of f is given by the gradient of f. So as an example, for a hiker, the gradient of f gives the direction of steepest ascent. The maximum value of the directional derivative, or rate of increase, is equal to the magnitude of the gradient of f, and the direction of maximum decrease of f is given by the opposite of the gradient of f. As an example of this, for a snowboarder, the opposite of gradient f indicates the direction of steepest descent. And the maximum decrease of the directional derivative of f, or the rate of decrease, is equal to the opposite of the magnitude of gradient f. And then finally, the gradient of f is orthogonal or perpendicular to the level curve at the point x comma y. It's also important to recognize that the gradient will change as soon as you move from a given point. So let's take a look at this graphically. So here we see the graph of our surface f of x comma y equals xy. We found the gradient at the point -3, comma 2, which is this red point here in the xy plane. To find the corresponding point on the surface, we have to substitute the x and y value from this point into our function, which would give us the z-coordinate, which would give us this point on the surface. Now this red vector that we're seeing here is actually the gradient of f, and notice how it's pointing in this direction, which means if we're on the surface at this point and we move in the direction of the gradient, we're going to be moving in the direction of the steepest ascent, or the direction in which the function f is increasing the most. And if we move in the opposite direction, which would be in this direction here, we'd be moving in the direction of the steepest descent, or the direction in which f decreases the fastest. But again, as soon as we move from this point, the gradient would change, and therefore our direction would change as well. Let's go ahead and rotate this so we can see this from different angles. Let's also look down on the gradient. So notice how this plane contains a tangent line to the surface in the same direction as the gradient. And then finally, if we found the magnitude of the gradient, which remember would be the length, if we move in the direction of the gradient, it's going to tell us how fast we're moving upward, or the rate of change of the function at that point in that direction, which is also the slope of the tangent line in that direction. And remember, this is the direction of maximum increase. I hope you found this helpful.